Hi, everybody. I want to talk about this problem, projectoiler.net, and it has to do with largest palindrome. This is problem number 4. Always, I strongly suggest that people look at projectoiler.net or LeetCode and practice problems on there. Anyway, what is a palindrome? A palindrome is a number, if it's a palindromic number, that goes backwards and forwards. It's the same thing. Like 9009 is the same forwards and backwards. There's a bunch of words that are famous palindromes. This is from Grammarly blog, and they just put up funny palindromes. A nut for a jar of tuna, you can read it either direction. Al ed Della call ed Stella. You can read it the other direction. And then they have a bunch of funny ones. Murder for a jar of red rum, and mom, etc. So anyway, they go through this. Are we not pure? No, sir. Panama's moody. Noriega brags. It is garbage. Irony dooms a man. A prisoner up to a new era. Can read it the other way. Are we not pure? Etc. So we're dealing with numbers, but strings are very related, and that's why I was mentioning that, because in theory, we may want to turn a string into a number or a number into a string. So the question here says that they take the largest palindrome of two-digit numbers, and a two-digit number is anything from 10 to 99, and they find that the largest two-digit palindrome number made from the palindrome made from two-digit numbers is 91 times 99. And our question is to find the largest product of three-digit numbers. That's a palindrome. So that means from 100 to 999. That's 3 digits. So what numbers can we multiply to get the largest palindrome from 3-digit numbers? That's the question. So what are the approaches to finding palindromes? Well, one approach is to reverse it, take a number like 1, 2, 3, 4, and then reverse it and see if it's the same. That's one approach. A second approach is to take the first number and the last number and see if they're the same. And then go to the next two, the second number and the second to last, see if they're the same. The third number and the third to last, see if they're the same, etc. So those are two fine approaches to checking if something's a palindrome. There is the question, though, is that there's, first of all, the reason why this is an important problem is because, well, first of all, how do you do that, obviously? And second of all, there's a bunch of edge cases that are important, such as what if there's zeros in there? How's that going to work, right? And if you reverse the number 1210, it's a little bit problematic because it just becomes 121. There's no zero in front. Now, obviously, it's not a palindrome, but if I were to have this as a string or something, okay. And different ways we do it may run into issues, which is something that I want to explore with you. The second thing is that an int is only a certain size, not that big. A double is big, but still not necessarily the size that we want. A big integer is as big as you like, so that's something that we want to explore using something called BigInteger. There's a Java library. There's a big decimal and big integer. So if you want to use something of arbitrary large size, you can use big decimal, big integer, and you can see that it's a little bit complicated to set up. You have to create an object to do it, and you would say new big integer and then put it in quotations. The other approach to get something big is to convert it into a string. So if you wanted to take a string and you had something like string.value of this number, so you have a number and then you want to convert it to a string, so it might be easier to reverse and palindromic and test for a palindrome that way. But also you could think of a number as a string and then you may need to process it that way and see what happens. So these are a lot of different points that we want to explore. Let's start in the simple cases and then let's move up. I have a lot of exploration here. Some of it works and some of it doesn't, and we want to see if we can figure out why. So let's first go to our basic thing over here with an int, and we want to reverse the number. So using a string to reverse a number or check is the same, is a little bit different than a int. So this int over here is going to have an n, and we set r equal to 0. Now I want to reverse a number. So let's say we had 1, 2, 3, 4. So you should recognize that if I take the mod 10 If I do it mod 10, that is the last digit. So that's the remainder I have to divide by 10. So let's just open up Excel and explore this just a drop to see how the math works for this. So make this a drop bigger so we can see it. Ooh, as big as it can get on my computer. No, it can't get any bigger. Let's see. There we go. All right. So if we have the number 1, 2, 3, 4, if I do it mod 10, that means I'm dividing it by 10 and getting the remainder. So if you realize how that works, the remainder is 4. Why? Because if you divide by 10, it's 123.4, and so it's 123 with a remainder of 4. Right? Because you just move the decimal over because it's 4/10, right? And if I were to do it mod this number, comma 100, that'd be the last two digits because I'm dividing by 100. So there's 12, it goes into 12 times plus 34 remaining, etc. So you could get the picture that whatever power of 10 you divided by, that's what you have. Now, if I wanted to get to look at the last digit, that's how I look at the last digit. If I want to go and get off the last digit, I need to do something like this, do that divided by 10, and then I'm going to take the integer part of that divided by 10, and that's going to be 123. So it's 123.4, and I take the integer part, and then that's 123. So that's the trick we're going to use over here, where we're going to say r is going to be 0. That's going to be my r for a reverse number. And I'm going to say while n is greater than 0, r equals r times 10. So you're going to take 0, you're going to multiply by 10, and you're going to say n mod 10. So n is the original number, and that was, let's just say 1, 2, 3, 4. So that's a 4 because it's mod 10. So you're really saying 0 plus 4. So you get 4, and that becomes r. Then you take n and you divide by 10. So it was 1, 2, 3, 4. Now it's 1, 2, 3. Then n is 1, 2, 3. So you take r, which is 4, you multiply by 10, so you get 40, and then you do n mod 10. So it's 1, 2, 3, so it becomes a 3. So you get 40 plus 3 is 43, so 4, 3, and that's r. Then you divide by 10. N was 1, 2, 3. Now it becomes 1, 2, because you're doing 1, 2, 1, you're doing integer division, getting rid of that. Then you do it again. So that's 4, 3, 0, because that's r times 10, plus n mod 10, 1, 2, 12 mod 10 is 2. So you get 430 plus 2 is 432, and then you get that. And n mod 10 is now 1, and then you add the 1, so you get 4321, and then you return it. So that's how we could reverse an int. Now, if we wanted to get the palindrome, public static void is palindrome int. I'm just going to say is palindrome int. You're going to give me the number, so int n, and what I'm going to do is I'm going to get the reverse of it. So I'm going to say int reverse equals, and I'm going to call this over here and get the reverse of n, and now I have the reverse. Okay, so if it was 1, 2, 3, 4, now I have the reverse. Now that's if you're passing something in. What we're supposed to get, and I could extend this a little bit, and I'm going to break it into small functions just to do that. So I don't really need to store it with anything. I just need to do a return statement and say if n is the same as that. So this is all that's actually necessary. Why is that all that's necessary? Because this is going to return a Boolean if it's a palindrome or not. And what's going to happen is it's going to just check if it's true. So if it's true that n is the same as the reverse, then it's a palindrome. And if it's not, then it's not a palindrome, right? So that's all we have to do. Just have to check to see if it's a palindrome. Now we have to check our values. So public static void is palindrome 3 digits, and what we're going to do, or let's just say highest, right? Highest or max palindrome of 3 digits. Okay, so I'm going to have a for loop, and this for loop is going to be going from 100, because that's the first 3-digit number, up until 1,000, one less than 1,000, which is 999, which is the last 3-digit number. And then it's going to be comparing for every j as well, from 100 up until 1,000. And I have to store the max somewhere. So I'm going to say int max. This may end up being a double. I don't know, but let's just go with the max for now. You know what? Let me actually just make it a long. The reason I'm going to make it a long is because I don't know if 1,999 times 999, I mean, I could just check, but if we want to generalize this, we'll make it a long. And you'll see where I'm going with this. So I'm going to call this max, and I'm going to set this equal to 0. And I'm going to set each of these to longs as well. Okay, and when you have a long, you add the L, so it's a long. Now, that's only 0, so it doesn't actually matter, but I'm just reminding you how to do that. So now what we're going to do is we're going to say if, so now what I'm going to do is I'm going to say long check equals I times J, and you can't put the L there, just showing you, but we do I times J. And now we're just going to say, we're going to check, check if it's a palindrome. So I'm going to say is palindrome int check. If that's true, then what? So if this is true, that that's a palindrome, when you check it, now what I'm going to do, so that takes in an int, so I'm going to have to make this a long as well. And then I'm going to make this a long just to be consistent over here. And now it's saying that this needs to be a long, and then this needs to be a long, and now I'm consistent with everything. Okay. Now, if it is a palindrome, now that you checked it, what are we going to do? We're going to say, store that as max. So then max equals check. Okay, so you keep doing that. So whatever the max palindrome is, if it is a palindrome, then I'm going to say if max is less than check, then, that's what I meant to say, then max is equal to check. So if max is less than check, so for whatever palindrome we hit, assuming there's one in there at least, then it will be that check is going to be max. And then you just keep going around and around and around. And once you're done, we can output the largest largest palindrome is, and we're going to say max. All right, so let's go and run my max 3 digits and see if it's going to work out. Oops. Okay, let's go run this and see if it's going to work out. I'm just going to get rid of this for now. And I'm going to say it's going to do the max. So max 3 digits. Oh, this is just a void, so I don't need the sout. So I'm just going to run this max palindrome 3 digits. Let's see what we get. Let's see if it makes sense. 906609. That looks about right, if I remember vaguely. And that's a palindrome, so we're on target. And we have that. Now, that was for 3 digits. Okay, so that was for 3 digits. Let's get back to where that was. That was for 3 digits. What if we wanted to, from 100 to 1000? What if we wanted to have any number of digits up until some long can deal with that? So max palindrome digits. Okay, so I'm going to we're going to now change this to be some number of digits. So int num digits. Okay, so now I'm going to have to set I and j. So if it's let's say it's a 3-digit number, so it starts at 100 and goes to 1000. So that's going to be from, let me just write it out. So I'm going to get rid of this long I, and I'll create that ahead of time, I and j. So I'm going to say long I equals math dot pow of 10 to the power num digits minus 1. So just to show that, this gives a double actually, so I'm going to have to convert it to a long. Let's see what it says is an issue. Oh, I wrote 2 equal signs, that's why. It could be that that doesn't even matter. I think I just wrote 2 equal signs. Yeah, no. I need to convert it to a long. Okay. So I'm converting it to a long, I'm taking it out, and I'm getting the num digits. So what's happening over here? If we had a 3-digit number, that's 10 to the 2. So it's going to be num digits minus 1. And j, long j equals the same thing, but it's 10 to the 3 for a 3-digit number because it's going 1 less than that. So that's what I have. So now I could actually do it to any number of digits. So if you wanted to know the num digits over here for 4, we can pass in a 4 and find out that the largest prime is that. Now, the reason that has to change is because I forgot to change the other part over here. So I is going to start at 10. So we're going to set it when I is equal to this. I guess I'm just going to, I could put it in here, but yeah, let's just do it. Let's just throw this whole thing in over here. So when I is that, and I'm going to go as long as it's less than the larger value. I guess I could put it in, but let's just set it up. So I'm just going to break this up. I know it's harder to read this way. Maybe it's just too hard to read this way. So I have a for loop. For long I is going to start at 10 and go up on as long as I is less than that. I'm going to do I plus plus. Okay, so let's check out what the problem is over here. The problem is that I already have an I. Let's see if that works. Yes. Okay, and then J is going to be the same thing. J is going to go from the 10, from the whatever value, to the, let's get rid of this, just copying and pasting, to the higher value over here, and it looks good. Okay, so we defined our higher and lower values. I just left it in that way. And now let's run this again for the max palindromes like that and see if it works. We get this number. Notice it took a little bit of time, and notice I spent palindrome wrong this whole time. But it took a little bit of time to get that. Now, it's going to take a little bit of time. 5, I'm a little bit hesitant to even do, but let's try it. Why not? See if it works, because long is only so big. So at a certain point, when you're multiplying the 99999 times 99999, it may be, and we're doing, it's big O of n squared, which means that we're doing an I, and for every I, we're doing every j, and we're counting it and doing it. So perhaps there's a better way to do this. Like just reversing the digits is not going to be, well, no, because then it's just the palindrome check. So perhaps there's a better way to do this. But you can see that 5 digits is already taking quite a long time to check. I'm just going to stop it over there, but I'm sure it works. We could just check 2 to see if our program works. And we do get, we get 9009, which was the largest palindrome for 2. Let me fix palindrome because I spelled it wrong. Okay, so that is doing it, the different steps. We found the different steps of the palindrome. Now, how else can we reverse a string, for instance? So I'm going to say reverse string over here. So in what I would do is I would basically, the way I check for a palindrome is I'd reverse the string and then see if it's the same as the original string. That's all I need to do to check. So, oh, this actually is palindrome, not just reversing. This does the palindrome check as well. So is or palindrome. I was right when I did it, string 2. Okay, so we start with a string, and we're going to do a for loop. And every time we're going until the end, we set R, which is empty, and we're going to add to it a new letter. So S is the original string we're doing, and this is assuming we're converting our double to a string. So we have the number 1, 2, 3, 4, or something like that. We just convert it to a string. And how do we do that? You say string.value of, and then you convert it to a string when you pass it in, and now you have a double, which is converted to a string. So R is empty plus S dot charat, S dot length minus 1 minus I. So the length is, let's say it's the numbers 1, 2, 3, 4, 5. So if we have the numbers 1, 2, 3, 4, 5, and we run it. The length is 5. The length is 6, right? Because the length of the word. Oh, let me go check this. Let's go check this because I'm thinking of the length of an array. So I'm going to run this, and I'm going to put 1 2 2 1 1 2 2 1. Okay, so we have a palindrome, and let's undo this over here, and we have. Oh, I'm doing the wrong one. Let's go and do the one that we need, which is palindrome, and it's called string 2, palindrome string 2. Palindrome string 2, and I'm going to pass in string. So I'm going to pass in this number over here, and we have that. So one too many of those. Let's see what else is wrong. It says, so that goes there. This goes here. Oh no, I have that. Okay, so let's just double check. Palindrome. It says cannot find simple palindrome 2 string 2. Let's check what it's called. I spelt it wrong here too. That's why it's not working. Oh gosh, now it can find it, palindrome string. So if we run this, we see it's true, this is a palindrome. But if I cut this off, then it's false, it's not a palindrome. Okay, so now we're back and everything is spelled right. So we're going to take our R and we're going to get the last letter, and every time we're going to do one letter less than the previous last letter. So if we had a string and the last letter was whatever, we do one less, one less, one less, because that's why the minus I is there. So you get the length of the whole thing, then you do one less every time, minusing the I as you go, and then you check is equals ignore case. So because some might be uppercase or lowercase, and then they might not be the same. So we're just going to say check if the two strings are the same. Now that's a regular test to do that. Now palindrome string number 1 is a little bit different, and this is going to check if it's the same, but it's going to work in a different way. It's going to do it instead of building a string and doing the reverse. It's just going to check the s dot char at I is not equal to s dot char at s dot length minus 1 minus I. So it's going to do the first one and the last one, and the second one and the second to last, etc. So if ever this one is not the same as that one, then return false. And if you get all the way through, then return true. So this will check if they are a palindrome. Okay, here's another one with a string, and this is going to check if it's a palindrome, but it's going to do it recursively. So if you have a length of 0 or 1, then we're done. It's not a palindrome, or it is a palindrome, I guess, because if it's 0 or 1, then you're done. It's a palindrome because it's just 1 or 0. Okay, but if s dot char at 0, if the first letter is the same as the last letter, s dot char less length minus 1, the last letter, then return palindrome recursive. Then do this again, but what should you take for the string? S dot substring, you take a substring up from 1, which is the second position, to s dot length minus 1, so to 1 less than what it was. So every time what you're doing is instead of taking the whole string, you're taking a substring which is going from one letter less on the inside and outside on the two sides. And then if you eventually get, and if every time you do this, right, if you do this, if it's the same, then you keep doing it. And if it's not the same, you return false. But if you got all the way down to 0 or 1 and you did them all, then it returns true. So that's how to do a palindrome recursively. This is a different way. And like we said, we saw 3 different ways. One is to create a reverse and then check if it's equals. The second is to check each letter. And the third is to do it palindromically, recursively, where you move in. Okay, so that is a bunch of ideas in this. Now, I want to talk about a big integer. This is another way to do it, which is you use a big integer. So this is not that hard if you do the reverse thing. So here's my idea. I'm going to take a big integer x. You pass me a big integer, a big long number, whatever it is, and I get a different one that's a reverse. Now, how do you get this? You take big integer, you new string builder x to string. So you take x, right? You make it to a string using a string builder, and string builder has reverse. So then you can reverse it. So you made the big integer, the big number, into a string by doing that toString, because big integer has a toString, and then a string builder has reverse. So now you reversed it. Now you make it back into a string, because then you do toString. Why do you make it back into a string? Because big integer can take in a string. It can't take in a string builder, it can take in a string. So you have this really crazy idea, which is that you convert it to a string and then a string builder, which has reverse, and convert it back to a string so that way big integer can take it. And now you have x, which is the number, and y, which is the reverse. And if x dot equals y, which is a method of big integer, then it is a palindrome. So this would work. It takes in a big integer. Okay, so that is a pretty in-depth approach to approaching different ways of doing palindromes. Now, I'm going to do now a couple other things in another video. I'm going to break it down and show a mathematical approach to dealing with big integer. And I'm going to also show what goes wrong when we do this approach. So those approaches I just showed you are fantastic. There are edge cases that you have to worry about, but overall, the big integer or string is going to be a very, very solid approach to getting large numbers and not worrying about certain things, at least the way that I did it. Okay, so in the next video, I'm going to explain what could go wrong if you take off numbers, kind of like I did with an int, but doing it with a big integer, and how zeros are going to actually mess this up, and how we can do a stack trace to figure out where our problem is, and all these different methods over here that I created to handle this, like getting a mod and etc.